Newton-Raphson method. See, using this Newton-Raphson method, what we do means for any given algebraic equation or for any given transcendental equation, we calculate its root, and those equation will be given in the form of f of x is equal to 0. So in today's class, what we are going to study means first we'll understand why we require Newton-Raphson method. See, to calculate roots, already we have so many methods like iteration method we have, bisection method we have, regular falsy method is there, even secant method is there. Then why we need to use Newton-Raphson method? What is the use of this Newton-Raphson method and how this method is different from the previous four methods? And also we are going to discuss the working rule, means how we need to solve the example with the help of Newton-Raphson method. And in this Newton-Raphson method, we have to use one particular formula, and that formula derivation also in today's class we are going to discuss. So let us start with its introduction. So in Newton-Raphson method, see, this Newton-Raphson method is also known as Newton method. Newton-Raphson method is also known as Newton's method, and in this very fast or very quickly we can calculate its approximation, means within first approximation or the second approximation almost will get our answer. So comparing to the previous four methods, bisection, regular falsy, secant method, iteration method, comparing to those four iteration method, those four numerical methods, this one is very fast. Very quickly we can find the approximate root for any given real valued function, that is f of x is equal to 0. Then what concept is there behind this Newton-Raphson method? See, this Newton-Raphson method uses the idea that a continuous and differentiable function can be approximated by a straight line tangent to it. Now what is its meaning? See, here we are using the concept of tangent. In Newton-Raphson method, very quickly we calculate its root for any given real valued function, that is f of x is equal to 0, with the help of straight line to the tangent. Just observe here. So let us consider x-axis and then y-axis. Suppose we have given an equation in the form of f of x. Then next, for the given f of x, if I draw curve. So consider here one curve, and this curve is for the given equation f of x. This is the origin. Okay, x-axis, y-axis, and in question there is equation in the form of f of x is equal to 0. For this f of x is equal to 0 equation, we are finding its root. So assume that this is the curve for given function f of x. Now what is this f of x is equal to 0 means? F of x is equal to 0. See, f of x is equal to 0. When we get this f of x is equal to 0 means when this f of x curve touches the x-axis. So at this particular point, the curve touches the x-axis, and this particular x value we are calculating, and this is only the exact root. This exact root we are calculating using Newton-Raphson method. So how we can reach to this exact value? See, this is the curve f of x, and this f of x touches the x-axis at this particular point. So this point is our required answer. So how we can reach to this particular point with the help of Newton-Raphson method? So in Newton-Raphson method, what we do means, initially one particular approximate value we need to consider. Initially one particular approximate value we need to consider, which is very near to this exact root. So let us consider one particular point and call this as x naught. So this x naught is what? This x naught is our initial approximation. Then this x naught we need to, from this x naught we need to draw a straight line to the curve, and this x naught touches f of x graph at this particular point, and this is x naught. So this particular point will be f of x naught. Then, so what we are doing means we have one function f of x, and this curve touches the x-axis at this particular point, and this point is only the required exact root. So this is only the required exact root. How we can reach to this particular point? For that we need to consider, we have to consider one approximate value, call it as x naught. From this x naught, draw a straight line to the curve, and this point will be f of x naught. Then at this particular point we have to draw a tangent. So one tangent line we need to draw from this one. When we draw a tangent line from this particular f of x naught, this particular point, then again we can observe that this tangent also cuts the x-axis. This tangent line again cuts the x-axis at this particular point. Now call this point as x1, because already x naught we have considered. Now next consider x1. Then the same process we need to repeat here. From this x1, again draw a straight line to the curve. Now this straight line touches the curve at this particular point. If this is x1, then this will be f of x1. Then again what? From this point we need to draw tangent line. So again from this we have to draw a tangent line. So we can observe this tangent line also cuts the x-axis. So this tangent line also cuts the x-axis at this particular point. So this is x naught, x1. Now call this as x2 and repeat the process here. From x2 again we need to draw a straight line. This is x2, this will be f of x2. Again same concept, from f of x2 draw a straight line. Then you can observe here this particular point comparing to x naught, this is very close to our required answer. This point is very close, very near to the required exact answer. So we need to repeat this process until we get the required accuracy. So till we get the required accuracy, we need to continue the process. So with the help of tangent line concept, we can reach out to the exact root for the given function, that is f of x. See, this is the concept here. And here x naught is what? This is the initial approximation which we are considering. This x naught is initial approximation which we are considering. From x naught will get f of x naught. Draw tangent line. Again one more point will get, that point is x1. From x1 draw straight line to the curve, will get f of x1. This f of x1 is nothing but, this is the result of after first iteration, or yes, first iteration. See, this f of x1 is after simplification of first iteration or first approximation. Then from this we'll get x2. From x2 again f of x2 will get, this will be our second iteration, means second approximation, and so on. The process continues and will reach very near to the required exact root. So this is the concept behind Newton-Raphson method, that with the help of tangent lines, with the help of tangent line concept, we are reaching to the exact root. So here you can observe it. Here I have considered x1 as the initial approximation. From x1, if we draw a straight line to the curve, we can observe that f of x1. This f of x1 is nothing but whatever the initial approximation we are considering. For that, this is the initial guess which we are considering. From this f of x1, draw a tangent line. It is a straight line. So draw a tangent line. Again, this tangent line cuts the x-axis at a point x2. Then draw straight line from x2, will get f of x2. This f of x2 is nothing but first iteration or the first approximate value. Again, from x2 draw a straight line, that is draw a tangent line. Then next we'll get x3 which cuts the x-axis. From x3 draw a straight line to the curve. Then we can observe f of x3. This f of x3 is nothing but second iteration or the second approximate value. So again, from x3 draw a tangent line, will get x4, and so on. We need to continue the process till we reach to the exact root, or till we get the exact accuracy. We have to continue the process. So this is the geometrical meaning for Newton-Raphson method, means how it works. This is the geometrical meaning for Newton-Raphson method. Then next, here we are using the concept of tangent line. So using this tangent line concept only, we derive formula for Newton-Raphson method. Because when we start solving Newton-Raphson method, we have to use one particular formula. So that formula, how we can derive. So let us observe formula derivation. This concept is also very simple one. So just observe how we derive formula for Newton-Raphson method. So here, let x0 be the initial approximate root for the given equation, and this x0 is very close to the root of the equation f of x is equal to 0. Initially what we do means we have to consider one x0 value, even though in previous classes, that is secant method, in secant method also we have selected one x0 value. In a similar way, for Newton-Raphson simplification also, in the beginning we have to consider one x0 value. That value is very close to the root of the equation, given equation f of x is equal to 0. Then after this, what we have to do means we need to draw a tangent line to the graph y is equal to f of x. See, at the point x is equal to x0, then this line has a slope f dash of x0 and goes through the point x0 comma f of x0. Now what is its meaning? Just observe here. Here we have one more diagram. X-axis, y-axis, then we have a curve, and this curve is y is equal to f of x curve. Then f of x is equal to 0 means when this curve cuts the x-axis, when this curve reaches the x-axis, means when it coincides with x-axis, when it cuts the x-axis, this particular point, this is what? This is the exact root which we are calculating. Okay, so this is f of x curve. Here we have f of x is equal to 0. So what we are doing means initially x0, one value we are selecting, that is x0. From this draw a straight line. Then the coordinate points will be, see how we write coordinate points. We write coordinate points using x comma y. So here x-axis value is x0 and y-axis value is f of x0. Therefore, the coordinate point is x0 comma f of x0. From this point, from this x0 comma f of x0 point, draw a tangent line. And even though this tangent line cuts the x-axis at a point x1, from x1 again draw a straight line, then we can observe that this point is x1 comma f of x1. And what about this particular point? When we write x1 coordinate point, then it is x1 comma 0. Why it is 0 means along x-axis y value will be 0. So if I write point for this x0, if I write point for this x0, then this is simply x0 comma 0, because along x-axis y value will be 0. So this is x naught comma 0, this is x1 comma 0. Okay. So with the help of this tangent line at a point x naught comma f of x naught and then x1 comma 0, further formula derivation easily we can consider. See, we have 2 points. Using these two points, easily we can write here tangent line equation for formula derivation. So ಇಲ್ಲಿ formula derivation ಮಾಡ್ತೀರಾ ಅಂತಂದ್ರೆ tangent line equation we need to consider. See, the standard formula for tangent line equation is y2 minus y1 is equal to m into x2 minus x1. This is the standard equation of tangent line. This is the standard equation of tangent line. That is y2 minus y1 is equal to m into x2 minus x1, where m is the slope of the given line. So m is the slope, then this x1 comma y1 and x2 comma y2 are the coordinate points. So here what we have, after drawing this curve and after considering this tangent line cuts at 2 points. That is, first one is x naught comma f of x naught and second point is x1 comma 0. So just consider this particular straight line separately. Just consider this particular straight line. So here one point is what? X naught comma f of x naught. Then another point is what? x1 comma 0. So first point is x naught comma f of x naught. Then next point is x1 comma 0. For this tangent, we are calculating its equation using y2 minus y1 is equal to m into x2 minus x1. This is nothing but the standard equation to calculate. This is standard tangent line equation. Now, in this equation, we need to substitute these 2 points. So here, what about x1 y1 and x2 y2? Consider this point as x1 y1 and consider this point as x2 y2. It means x1 value is x naught, y1 value is f of x naught. Then x1 value is, y2 value is x1, y2 value is 0 and x2 value is x1. So these 4 values we need to substitute in this equation to get the formula. Then next, this is about x1, x2, y1, y2. Then what about m? Here m is the slope of the line. See, for slope we have dy by dx concept. Slope is equal to dy by dx. Now what is this dy by dx? Derivative of y with respect to x. This is the first order derivative. So in this example, what is the given function? The given function is y is equal to f of x. When I take its derivative, then what it will be? F dash of x. So derivative of f of x is f dash of x. But at which particular point we are selecting? We are selecting at a particular point, that is f of x naught. Therefore, here this m we have to consider as f dash of x naught. So the derivative is f dash of x naught. We have to consider f dash of x naught. See, this line has slope f dash of x naught. Based on that, further calculation we have to simplify here. See, in this formula we are substituting x1, x2, y1, y2 values. So what about y2? What we can observe? In place of y2 we have 0. So substitute. Then what about y1? So in place of y1, so y1 is representing by f of x naught. Then m means what? M is the first order derivative, that is f dash of x naught. Then x2 is what? x2 is x1. Then x1 is x naught. So after replacing the coordinate point and the slope value, we have got this one. Now further thing is just simplification. 0 minus f of x naught is minus f of x naught. Then write f dash of x naught as it is. Then x1 minus x naught as it is. Next, what we can do here means take this f dash of 0. this f dash of x naught is what? This is multiplied. So multiplied term, if we take left side of the equation, then it will be division. So in next step, minus f of x naught divided by, take this one, that is f dash of x naught, which is equal to x1 minus x naught. So what we are calculating means, we are calculating here first approximation. First approximation means x1. For that, take this minus x naught left side, then plus x naught it will be. So x naught minus of f of x naught divided by f dash of x naught, which is equal to x1. Therefore, the required first approximation, that is x1 derivation, is x1 formula is x naught minus f of x naught divided by f dash of x naught. This is the required first approximation formula. So with the help of this formula, we can calculate easily first approximation, that is x1. So x1 is equal to x naught minus f of x naught divided by f dash of x naught. So if you are using Newton-Raphson method, then you need to remember this particular formula for calculation of approximate root. So here this is the tangent line, therefore we are using tangent line equation, that is y2 minus y1 is equal to m into x2 minus x1. This is standard tangent line equation. Then next we are substituting the values, rearrange the terms, then we'll get here x1 is equal to x naught minus f of x naught divided by f dash of x naught. This formula you need to remember to calculate first approximate value. Then next, here the point x1 is the first approximation to the corresponding root. By continuing this process, we get better approximation. Means after first approximation, go for second approximation. Now second approximation, how we can write here? The first approximate, what we have got here formula? We have got formula, that is x1 is equal to x naught minus f of x naught divided by f dash of x naught. Using this, we can calculate first approximation. Then to calculate second approximation, how we can write it? In place of x1, write x2. So x2 is equal to x1 minus f of x1 divided by f dash of x1. This is to calculate second approximate root. Then next, to calculate third approximate root, we have x3, that is x2 minus f of x2 divided by f dash of x2, and so on. This process continues. And then what about its general or the standard nth form, that is x of n plus 1 is equal to xn minus f of xn divided by f dash of xn. So and so on. When we continue, we can observe the general form, that is x of n plus 1 is equal to xn minus f of xn divided by f dash of xn. This we have derived, that is x1 is equal to x naught minus f of x naught divided by f dash of x naught. This is to calculate first approximate root, second approximate root, third approximate root, and so on. Lastly, the general form which we get is xn plus 1 is equal to xn minus f of xn divided by f dash of xn. This is the general form. So here, this is to calculate the first approximate root, and so on. If we continue, then we can generate here the general equation, that is xn plus 1 is equal to xn minus f of xn divided by f dash of xn. This is about the formula derivation. It is very simple one. You need to understand this diagram and you need to remember tangent line equation. In that, replace these 2 points value and remaining is just rearrangement of the terms. So when we are solving Newton-Raphson method, we need to remember this particular formula to calculate first approximation, second approximation, and so on, the further approximate values. See, as we know, this Newton-Raphson method is very quick. Means within few iterations, we reach out to the exact root. Hardly one or two, within one or two approximate values, we can reach to the approximate values. Then what about its working rule? Now just observe the last part, that is the working rule, means how we need to solve example using Newton-Raphson method. See, first step is similar First step is similar to your previous methods, that is, we have to consider the given equation, that is f of x is equal to 0 as it is. So let f of x is equal to 0 be the given equation. Then what we have to do means, for this given equation we have to consider its first approximate root, that is x naught. So we need to find, or we need to consider the first approximate or the initial root x naught. See how we have to consider this x naught means, f of x naught is near to 0, means this x naught value when we substitute in this function, the value should be near to 0. In that way we have to select this x naught. Then after considering x naught, we have to calculate f of x naught and f dash of x naught. Why these two values are required means, to calculate first approximate we have this particular formula, and in this formula what we can observe, f of x naught is there and even f dash of x naught is there. For that, once we consider the initial root, that is x naught, we have to calculate f of x naught and f dash of x naught. Then after calculation of these two values, we have to find the first approximate root by using Newton-Raphson method, that is using this particular equation, x1 is equal to x naught minus f of x naught divided by f dash of x naught. Then once we calculate x1, again we have to find f of x1 and also f dash of x1. Now f dash of x1 means it is derivative value. F of x1, f dash of x1 we need to calculate. After this we have to go for second approximate root using the formula x2 is equal to x1 minus f of x1 divided by f dash of x1, and so on. The process will continue till we get the required or the desired accuracy. We have to continue.